This video is all about a geometric problem where you where we are given angle BDA as 80 and angle CBD as 40 and angle BCD as theta. Now we are asked to find theta. Now let's begin. Now let's begin. There are two methods we are going to use to solve this particular problem. Now let's start with the first method. Now let's start with the first method. Now let me draw the diagram here. Let me draw the diagram here. Now you have here as your A, B, C, and here is D. Now here is 40 degree, here is 80, here is theta. Now we're asked to find theta. So but what I will do now, I will just extend the line, and here is equal to this place. Now I'll just extend the line from BD. Then I will now draw a line in such a way that a line to meet this extended line from BD at E in such a way that this angle, this side here, CE, is equal to DE. So in such a way that that is equal to that. So now, so having done that, we'll now look at now in triangle ABC, we have BAC, triangle BAC plus triangle, sorry, not triangle, angle ABC plus angle ABC plus angle ACB is equal to 180. That is sum of angles in a triangle is equal to 180. So now we have BAC is 80 plus, we don't know, angle ABC plus angle ACB is what? Theta, which is equal to 180. The total is equal to 180. Now let's move this 80 to this other side and theta to this other side. You have angle ABC equal to 180 minus 80. 180 minus 80 minus theta. So this will give us 100 minus theta. So angle ABC is equal to 180 minus theta. Now let's now look at in triangle BCD, the sum of angle lies, you have DBC plus angle BCD plus angle CDB is equal to what? 180. That is sum of angles in a triangle equal to 180. So now DBC is 40 plus angle BCD is theta plus angle CDB is 40 plus theta plus angle CBD is equal to what? 180. Now moving this to the right hand side, you now have angle CDB equal to 180 minus 40 minus theta. So this is equal to 140 minus theta. So CDB, angle CDB is 140 minus theta. Now, so here is 140 minus theta. So it's 140 minus theta. So when you look critically again, angle on a straight line, let me now draw it here again. Draw the diagram here again. You have something like this. You have A, B, C, D, E. We have here to be equal to this place too. Then here is 140 minus what? Theta. Here is theta. Here is 40. Now here is 80. Now B, D, E is a straight line. It's a straight line. So angle BDC plus angle CDE is equal to 180. Angles on a straight line is equal to 180. So we have BDC to be 140 minus theta plus angle CDE equal to 180. So now, if you move the whole of this to this other side, you now have angle CDE equal to 180 minus 140 minus theta. So you now have 180. Open up this bracket, you have minus 140 plus theta. So this will give you 40 plus theta. So angle CDE is equal to 40 plus theta. So since here is equal to 40 plus theta, and in triangle CDE, side CD is equal to side CE given. It's given. So now it now means that triangle CDE is an isosceles triangle. So an isosceles triangle in which you have two sides equal, then the base angles are equal. So that means angle CDE is equal to angle DEC, which is equal to 40 plus what? Theta. So here is 40 plus what? Theta, which is, we call it base angles of isosceles triangle. Isosceles triangle. So now, having shown this, now if you look at, let me now also draw a sketch again here. There's A, B, C, D, E. We now have here to be 40 plus theta. We have here to be 40. We have here to be theta. We have here 80. So in triangle BCE, we have angle CPE plus angle BEC plus angle ECB equal to what? 180. Sum of angles, sorry, angles of a triangle is equal to 180. So CBE is 40 plus BEC is 40 plus theta plus, now we're looking for angle ECB. So 40 plus 40 plus theta plus angle ECB is equal to what? 180. So 80 plus theta plus angle ECB is equal to 180. So now moving the whole of this to this other side, you now have angle ECB equal to 180 minus 80 minus theta. Or you can say in brackets like this, so which is 180 minus 80 minus theta. So this is same thing as 100 minus theta. So angle ECB is equal to 100 minus theta. So we have here to be 100 minus theta. Now, and angle, if you can remember, initially the angle ABC is equal to 100 minus theta, and this place is equal to 100 minus theta. So it now implies that angle ABC is equal to angle ECB. So now let's now look at these triangles. You have this triangle like this, you have the next one like this. This is A, B, C. This one is B, C, E. Now here is 100 minus theta. Here is 100 minus theta. Here is what? 40. Here is 40 plus theta. Sorry, let me write it this way. 40 plus theta. Here is what? 80. Here is theta. Now let's look at this. This place is equal to this place given. Now let's look at the similarities of these triangles. Now you have AB equal to CE given. Now, and you also have angle ABC equal to angle BCE proved above. Now you also have side BC equal to BC. This is common to both triangles. It's common to both angles. So it that means that triangle ABC and triangle BCE are congruent triangle. So it now shows that triangle ABC is congruent of triangle BCE in so it is congruent, so which means that you have side A, side angle side congruence. Triangle. So the type of congruence is side angle side. So now that means that if you now look at side BC, side BC is adjacent to two angles. It has for in okay, now let me now delete this for for triangle ABC. BC is adjacent to two angles. It's adjacent to two angles, which is angle A, BC, and angle angle BCA. Now for triangle BCE, BC is adjacent to angle BCE and angle CBE. Now, if you look critically, angle ABC is equal to angle BCE. This is proved above. Now, but since they are similar, that means since they are congruent, that means angle CBE will be equal to angle ACB. So this is CPCT, that is corresponding parts of congruent triangle. So if you check now, the corresponding part of this angle is this side, because they have BC common. This is BC, BC is common here. You have this angle, you have it here. Then this one is 40, this one is so that means this one is corresponds with this, meaning that theta is equal to what? 40. 40. Okay, this is 40 equal to theta. So, but anyway, same thing. So that means theta is equal to 40. So that is it now. So now let's now do the other one. Now the other one, the second method. The second method. Let's now draw the diagram. Okay? You have here to be 40, here is 80, here is theta. You have A, B, C, D. Now for the second method, you know the area of a triangle, if you have a triangle like this, now you have A, B, C, and there is an angle here, let's say alpha. Now the area of this triangle, let's say you now draw a vertical line, a line that is perpendicular to this other line, and that forms an angle 90. So that means here is the height, and this AC is the base. So let me say it cuts at D. Now that means that the area of this triangle will now be half times the height. Half times base, that is half times height. Height is BD times the base, which is AC. Now, using the trigonometric formula. Now, also using the acronym SOHCAHTOA. Now you have sine alpha equal to, here is opposite to this angle, that is opposite all over hypothesis. Now this is opposite to this angle, which is BD divided by the hypothesis, which is AB. So that means if you cross multiply, BD will now be equal to AB sine alpha. Now, if you now substitute this BD into here as this, you now have the area of the triangle equal to half AB times AC sine alpha. So that means if you have an angle here, the area of that triangle will be this AB, this side times this side, half this side times this side, with sine of this angle that these two sides forms. So that is what we're going to use here now. So here now, this is the, so in triangle ABD, the area of that triangle will now be half times AB times AD times sine 80. So this side ABAD forms an angle 80. So to be sine 80. Now you know the angle here is equal to the sum of these interior angles. The external angle of a triangle is equal to the sum of the interior angles. So now, then that means that now we have gotten this. So now it now means that the angle ADB is equal to angle DBC plus angle BCD, which is 40 plus what? Theta. So angle ADB is 40 plus theta. So here is equal to 40 plus what? Theta. So now using that same angle to also find that same area in that triangle, in triangle ABD. So now that means we have the same area equal to half times AD times BD sine this angle here, because these two sides forms this angle 40 plus theta. 40 plus what? Theta. Now we have gotten that. Then now let's now equate them. Since this and this are the same, let's equate it. Now equating those things that are the same, let me call it equation 1, equation 2. So since this area, so since this is the area of the triangle in different forms, so that means they are equal. So let's equate them. So since they are the same, we just equate them. So now you have half AB times AD sine 80 is equal to half AD times BD sine 40 plus theta. Now, the half is common, we'll cancel them off. The AD is common, we'll cancel it off. So now you now have AB sine 80 equal to BD sine 40 plus what, theta. Now let's assume this is equal to this. We assume it's A. So that means AB is equal to A. So let's substitute AB as A. So we have A sine 80 equal to BD sine 40 plus theta. So dividing both sides by sine 80 sine 80, this will cancel out. You now have A equal to BD sine 40 plus theta divided by sine 80. So this is equation 1. This is equation 1. Then now let's say in triangle BDC, the area of the triangle is equal to half times, like this is BDC. So the area of this triangle is equal to half times BD times BC times sine 40. And it's also the same thing as saying, also the same thing in another form. The area is also half times DC, which is DC here, times BC times sine of this angle, which is sine theta. So the half is common, we'll cancel them off. BC is common, we'll cancel it off. Now we are now left with BD sine 40 equal to DC sine theta. This is sine theta. So we now have BD sine 40 equal to DC sine theta. DC is equal to A. So that means DC sine theta, which is equal to BD sine 40, dividing both sides by sine theta, this will cancel out. You now have DC, which is A, is equal to BD sine 40 divided by sine theta. Now, since this is equation 2, now since A is equal to this and also A is equal to this, so now we can now say BD sine 40 all over sine theta, which is equal to A, is also equal to BD sine 40 plus theta divided by sine 80. So BD will cancel each other. We now have sine 40 divided by sine theta is equal to sine 40 plus theta divided by sine 80. So if we cross multiply, we now have sine 40 times sine 80 equal to sine 40 plus theta times sine theta. Now multiplying both sides by 2, you have 2 sine 40 sine 80 equal to 2 sine 40 plus theta sine theta. Now we know that cos A minus B is equal to cos A cos B minus sine, okay, no, plus sine A sine B, equation 1. Now we also know that cos A plus B is equal to cos A cos B minus sine A sine B. Okay, let me just say 3, 4. Now, with this expression, let me write it properly. You have cos A minus B equal to cos A cos B plus sine A sine B. You have cos A plus B equal to cos A cos B minus sine A sine B. Now, let's say we wrote this equation 3, equation 4. So now subtracting equation 3, equation 4 from 3, you now have cos A minus B minus cos A plus B is equal to, now if you put minus here, this will cancel out. You put minus here, here becomes plus. So you have 2 sine A sine B. Now let's look at this equation now. You have 2 sine 40 sine 80 equal to 2 sine 40 plus theta, 40 plus theta sine theta. Now using equation 5, you will now notice that now for using equation 5, for 2 sine 40 sine 80, you will notice that A is equal to what? 40, while B is equal to what? 80. Now substituting that into equation 5. Substituting that into equation 5, you now have 2 sine 40 sine 80 equal to cos. Now A is 40 minus 80. Now minus cos A plus B, which is 80, sorry, 40 plus 80, which is 40 plus 80. Now that means 2 sine 40 sine 80 will give you cos minus 40 minus cos 120. So we have cos minus 40 minus cos 120. Now if you're moving in this quadrants, if you're moving counterclockwise, it is positive. Now if you're moving clockwise, it's negative. So now minus 40 will just be like this. So now it falls on the fourth quadrant. And on the fourth quadrant, it's only cos that is positive there. Here, all is positive, only sine is positive in the second quadrant. At the third quadrant, only tan is positive. Then in the fourth quadrant, only cos. So now that means cos minus 40 is equal to cos 40. So it now implies that 2 sine 40 sine 80 is equal to cos minus 40 minus cos 120 is equal to cos 40 minus cos 120. So we have come to this. Now for sine 40 plus theta sine theta, for 2 sine 40 plus theta, so now A is equal to 40 plus theta, while B is equal to theta. So plug it into equation 5, this equation. You now have 2 sine 40 plus theta sine theta equal to cos A minus B. You have 40 plus theta minus theta minus cos 40 plus theta plus theta. This will be equal to, this will cancel out this. You have cos 40 minus cos 40 plus 2 theta. Now, so you now have 2 sine 40 plus theta sine theta equal to cos 40 minus cos 40 plus 2 theta. So since 2 sine 40 sine 80 is equal to 2 sine 40 plus theta sine theta, then cos 40 minus cos 120 is equal to cos 40 minus cos 40 plus 2 theta. So this is common, they'll cancel out. You now have minus cos 120 equal to cos minus cos 40 plus 2 theta. 2 theta. So that means, so there is minus here, minus here. So let's divide both sides by minus 1. So if you divide both sides by minus 1, this minus will cancel out this here. You now have cos 120 equal to cos 40 plus 2 theta. Now, since the cos are common, we just cancel it out. You have 120 is equal to 40 plus 2 theta. Now, if you move this to this other side, let me interchange. I have 40 plus 2 theta equal to 120. Now, move this 40 to this other side. I have 2 theta equal to 120 minus 40, which is 80. Now, that means you have 2 theta equal to 80. Dividing both sides by 2, you have theta equal to what? 40. So 40 is the answer, final answer. Thank you for watching till the end. Have a nice day.